Welcome to exercise 9, CE9s. This is Monday's class, and we're going to spend 2 sessions on this topic, and it's talking about using set notation. So what are set notations? It's basically all the symbols that we encounter in probability. For example, sample space. Sometimes you'll see it as the omega symbol, or you might see it as a squiggly E, or the U, or the S. I think I'll go with the E, just because that's what I grew up with, but if you want to use any other symbol, go for it. Set A is a particular subset. Whenever we see subset, we use this little rounded side curve, and all it means is the way it points is pointing to the subset. For example, if our entire sample space is 1 to 10, 2, 3, 5, and 7, we can say is a subset of this sample space. Okay, so we just point the little side curve to the subset. A dash is the complement, so all the elements that's not contained in A is what we call the complement. Again, we'll take a look at some examples later on. 5 is an element of A, meaning 5 is one of the numbers in set A. 0 with a dash through it means null or empty set, and there are no elements within that set. N with the brackets just means the number of. Here we've got our two-way table and Venn diagram that we had a look at in exercise 9b. And whenever you see a little arc that's pointing upwards, that's talking about the intersection, which is a point in the middle. If you see the little union symbol, or the upside down arc, that's what we call the union, and that includes everything in all 3 sections of the circle in a Venn diagram, of course. Yeah, let's take a look at some examples. So let's put this to context. So a number is chosen from the set of positive integers, just positive whole numbers, in other words, between 1 and 15 inclusive, so including the numbers of 1 and 15. A is the set of odd numbers between 1 and 15, and B is a set of prime numbers between 1 and 15 inclusive. So let's just underline the key detail. So set A, set of odd numbers. B is a set of prime numbers. All right, we're dealing between 1 and 15. So let's say sample spaces. Let's use our sample space symbol. Go with the squiggly brackets. Our sample space is all the numbers from 1 to 15. All right, pretty easy stuff, and then shut the bracket. Sorry for the messiness, it is what it is, just got to deal with it. Set A is all the odd numbers. So what we do here is we say, maybe if I zoom in, I can squeeze everything in. All right, so set A here, we have our squiggly set bracket. Odd numbers, so 1, 3, 5, 7, 9, 11, 13, and 15. Remember, it says inclusive. And then we shut the brackets off. Set B are prime numbers. So prime numbers are numbers that have 1 and the number itself as the factors, except 1 is an A prime number. 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is not 9 because you have 3 times 3 and 1 times 9, but 11 is a prime number, 13 is also a prime number, 15 is not because you've got 1 times 15 and 3 times 5. So we have our 2 sets. From here it tells us to draw a Venn diagram. Remember, with our Venn diagram, we have a big rectangle that encompasses the 2 circles. Let's call this left circle, circle A, right circle, circle B. What we need to figure out is the number of numbers that overlap between the two sets. So we have 3, 5, 7, 11, and 13. They all overlap. All right. So how many is that? That's 1, 2, 3, 4, 5. So we have 5 numbers in total that overlap. Let's see. So that means A has 1 number, 2 numbers, 3 numbers by its own. That's not overlapping in B. And the numbers that's in set B that's not overlapping with set A is just a 2. So we have 1 there. And what we do here is we add up 3 plus 5 plus 1. So 3 plus 5 gets us 8. 8 plus 1 gets us 9. We had 15 numbers in total, so that means 6 numbers are not in set A or B. Hopefully that makes sense. And we've constructed our Venn diagram. After that, what we have to do is we have to analyze this Venn diagram now. So for this first part, what numbers, in other words, so list C sets, what numbers are in A and B? So what number is in A and B? Well, we can't just write 5. We have to list out the actual set. So we say A and B equals, all them underlined in black, 3, 5, 7. So 3, 5, 7, 11, 13. All right, so we had 3, 5, 7, 11, 13. What numbers were in A or B? This one's going to include every number. That's 9 numbers in total. So every number that was in set A or B, we had 2, 3, 5, 7, 9, 11, 13, 15. All right, so let's write all that down and see if we have 9 numbers. So we add 2, 3, 5, 7, 9, 11, 13, 15. That's 1, 2, 3, 4, 5, 6, 7, 8. Did I miss a number? I forgot about the 1. So there was a 1 as well. Let's erase that. We can say there's 1, 2, 3. There we go. There's 9 numbers there. All right. So hopefully that's making sense so far. Here we've got all the numbers or all the elements that aren't in set A. So not in set A would just mean B. And everything else on the outside of that circle too. So everything that was basically an even number is not in set A. So we can say A complement is 2, 4, 6, 8, 10, 12, 14. And lastly, which numbers were in B only? So in B only, we had just 1 number, which is a number 2, underlined in blue. So B only, equals 2. And we've listed our sets. All right, so whenever you hear or see the words list, we have to put the set brackets in and write down each and every number that's in the sets. Okay, so hopefully that's made some sense. And let's take a look at the next one. This is our last set of examples. It says find the number of elements in A. So how many elements did we have in A? So the A circle, common error, people usually just choose A only. The A circle actually includes the middle as well. So we can say there's 8 elements in set A. So number of elements in A equals 8. So notice how whenever we have n and brackets, we're not told to list, so we don't have to write every number that's in set A, we just write the total. That's the difference between example C and example D. Now we have probability of getting an element out of set A. So how many numbers do we have in total? We had 1 to 15. So we had 15 numbers in total. 8 of them were in set A. So the probability of drawing a number that's in set A would be 8 out of 15. So notice how the PR and the N is different. So whenever it's N, it just wants a number. Whenever it's PR, it wants the probability or the fraction. Here we're asked how many elements are in A and B. Well, A and B is this intersection here in the middle, and we've got 5 numbers. So here we've got N, A and B. Number of elements in A and B is 5. Then it asks for the probability of A and B. Well, there's 15 numbers in total. 5 of them are in the middle. So the probability of drawing a number that's in A and B is 5 out of 15. Or alternatively, you can simplify it down to 1 and 3. You don't have to do that, but might make it a little bit easier to understand. For exercise 9C, please do all the questions from 1 to 7. Remember, we have 2 lessons on this, so Wednesday's single at session 3 will be this as well. Thanks, guys.